Okay, let's get started. Water is the only substance that can be all three states at one time: solid, liquid, and a gas. Water keeps us alive. We're on this earth because of water. Well, not exactly, but it keeps us alive. Water is 70% of the human body. It aids in digestion, cell growth, and keeps you hydrated. Now that we know what water does, what is water made of? A water molecule consists of 3 atoms, 2 hydrogen and 1 oxygen. Water's molar mass is 18.02 grams per mole. Now that we know what water is made of, let's do some experiments. See how it's not boiling and it's not at 100 degrees Celsius? But it still has vapor. Why is that? Now, let's talk about heat fusion for a second. Heat fusion is when a solid heats up to a liquid. This normally happens around 6.0 kilojoules per mole. The specific heat capacity is the amount of energy required to raise the temperature per unit of mass. It can be shown in joules per kilogram times Kelvin or joules per mole times Kelvin. We can use the specific heat formula to find the amount of heat per unit of mass to raise the temperature 1 degree Celsius. The specific heat of water is 1 calorie per gram degree Celsius. Now, let's try and melt an ice cube. When the ice is melting, the polar covalent bonds in the ice are breaking and turning to weak hydrogen bonds, turning it into a liquid. So, what's the melting point of ice? That's right, it's 0 degrees Celsius, the same as the freezing temperature. Do you know water expands when it freezes? Let's do an experiment. I'm gonna draw a line where the water is right now, and we're gonna put it in the freezer. And when it freezes, we're gonna see if it expanded. So now that the water's frozen, we can check. See how the ice is over the line now? That means when the water froze, it expanded.
Alright, so here we have 2 cups of water. In this cup we have dissolved 1 teaspoon of sugar. In this cup we dissolved 1 teaspoon of salt. We use the solution process of mixing 2 or more pure substances. They both dissolve in the water, and that's because water is the universal solvent and can dissolve most solutes.
Now that we know that water is the universal solvent and can dissolve most solutes, let's try some olive oil. See how the oil and the water are still separated? This means that it's a heterogeneous mixture and that it's a suspension because the 2 substances remain physically separated. So if this is a suspension, what would be the opposite? The opposite of a suspension is a colloid. A colloid is a solution that has particles that are super small, 1,000 to 1 nanometers in diameter to be exact. And all of these super small particles have to stay an equal distance away from each other to be a colloid, like fog or steam from a shower. You can't see it, but all these super small particles are exactly the same space apart. This space is what led to the Tyndall effect. The Tyndall effect is the effect of little particles reflecting light. Like in the fog when you're shining your light, it looks a little fuzzy and different than normal. That's because of the particles reflecting the light and the space between each particle. Let's talk about non-electrons and electrons. Electrons are molecules that ionize in a solution, and non-electrons do not turn to ions in a solution, like electrons do. Water makes the towel wet because it's chemically bound. So the molecules are in definite proportions relative to other ions. So when the water molecules hit the towel, they attach to the surface of the towel and make it feel wet. A paper clip is more dense than water, so it should be able to sink. But if you keep the surface tension and you don't break it, it will float. See how the water has kind of a skin? Well, that's because the water molecules are adhering around the bottom and the sides of the paper clip, holding it up. But if you break the tension, it'll sink. The brown in motion means I can put food coloring in a cup of water, and without me doing anything, it will begin to mix into the water. This is because the molecules of the water and the molecules of the food coloring bump into each other, and the spaces in between each molecule of both the food coloring and the water cross. Well, that's all for today. See you next time on the Kind of Bill Nye Show. Do you know how many calories are in that?
There's no calories in this. Food coloring is the amount of energy it takes to raise the temperature of 1 gram of water by 1 degree Celsius.
No, heat calories is raising the 1 gram of water by 1 degree Celsius. I'm talking about food energy.
Wait, isn't joules energy?
Joules is equal to the work done by the force of 1 Newton.
Oh, I get it.
A water mole. Yep. Okay. Yeah, you didn't go. Hi, Maya.
What are you doing?